Okay, so the first video dealt with lessons 1 and 2. This one's going to deal with lessons 3 and the last one. Okay? So for 20 through 24, we're going to use this figure, and I'm telling you that y is the centroid of triangle UTV. So these are all medians. UZ is a median, TW is a median, XV is a median, which means it goes from a vertex to the midpoint of the opposite side. So I know that these two are equal because that's the midpoint. I know Z is the midpoint, so these are equal. And I know W is the midpoint, so I know these are equal. Okay? So, since y is the centroid of the triangle UTV, classify XV, kind of already did this, WT, and UZ, they are all medians. Medians meet at the centroid. Okay. If YW is 11, then TY is 22, and TW is 33. Okay, so this is the relationship. The short piece is half the distance of the long piece of the median. Now, how do I know it's a short and how do I know it's long? It's always from the midpoint to the centroid is half the length from the vertex to the centroid. Easier way to think about it, from the vertex to the centroid is double the length of this. So if I know this is 11, I double it and I get that. Okay, so we'll do it again. If UX is 14, this time, I didn't give you the from the vertex to the centroid, I gave you a side of the triangle. If UX is 14, then XT is also 14, and UT is 28. Oh, by the way, back up here, I know that's 33. I just added those two together. Okay, if VY, so now I'm giving you from the vertex to the centroid, is 52, then XY, that's the shorter piece, because it goes from the midpoint to the centroid. So it's half of 52, so that's 26. And then I just add those up, and I should get 78 for the whole thing. The last one's probably the hardest. If ZU, the whole thing, is 12, then what's each piece? Well, I know that this has to be twice as big as X. We'll call this X, the smaller one X, this one's twice as big. So then 2X plus X we know has to equal 12. 3X equals 12, X equals 4. So the smaller piece, YZ, is 4, and the larger piece is 8. Okay. So that's dealing with the centroid, the relationship between the lengths in a centroid, or with the medians. Okay. For 25 through 30, you're going to classify AB as a midsegment, altitude, angle bisector, perpendicular bisector, median, or none. Okay? So, 25, looking at the markings is the key thing here, and where the line is going. So from A to B, so it's going from the vertex. We don't know if that's the midpoint, so we can't say it's a median. All we know is that those two things are equal. Those are angles. Those are equal angles, so AB is an angle bisector. AB, well, I see these are midpoints, so it's a midpoint connected to a midpoint. It's not a median, because a median connects a vertex to a midpoint. A midpoint to a midpoint is a midsegment. That is what we did in the first video, this first lesson in this unit. Okay, 27, AB from a vertex to the midpoint. I know it's the midpoint because these are marked. So from the vertex to the midpoint is a median. Okay. This is A and B, neither one is at a vertex. This is not, it's not a midpoint. B is not a midpoint. This is nothing. Okay. Perpendicular, so it's AB is perpendicular to that side. It's perpendicular, but it also goes through the middle. A is the middle because those are equal. So it's a perpendicular bisector. Okay. And number 30, from a vertex perpendicular to the opposite side, this is an altitude. Okay. All right. Back page. Done. Now I'm identifying the center being described. So again, you're identifying, kind of like we did just on those last 6, we're identifying the types of lines. but you're also identifying characteristics. So what is this showing? This is showing that it looks like perpendicular bisectors, but we don't know that because we don't know if this is the center. So it's not perpendicular bisectors. What it's showing is the distance from here to here is the same to all three sides. So it's equidistant to the three sides. Which center is equidistant to the sides? Okay, I just want to make sure this is what this is showing. It's equidistant to the sides. That would be the in-center. Okay, very similar, but this one is showing perpendicular bisectors. Notice what's marked congruent in this one. Notice what's marked congruent in this one. That's a midpoint. That's a midpoint. That's a midpoint, and they're all perpendicular. So these are all perpendicular bisectors. The perpendicular bisectors meet at the circumcenter. Okay, 33. These are all medians because they go from my vertex to the side opposite, and it is the middle, all three of them. So the middle of each side is those are medians. The medians meet at a centroid. 34. What this one's showing is that the distance from the center to the vertex is the same. So equidistant to vertices is what this one's showing, and that would be the circumcenter. This one's showing from the vertex perpendicular to the opposite side, perpendicular, perpendicular. Those are all altitudes. The altitudes all meet at the orthocenter. And the last one, these are all angle bisectors, and angle bisectors meet at the in-center. Okay. 37. At a beach recreation center, there is a volleyball court, a tennis court, and batting cages. The recreation center wants to build a pavilion that is equidistant from each event site. So you got 3 points, and you want to have something that's equidistant to the 3 points. You've got this situation right here. So you can say you got recreation center, volleyball court, and volleyball court, tennis court, and batting cages. And you want something in the middle that's equidistant to all of them. That would be the circumcenter. Baldwins want to install the largest possible circular pool in their triangular backyard. Where would the largest possible pool be located? Okay, so the pool it's going to be this right here. You're going to want a pool that is equidistant to the sides. So that's going to be the in-center. Okay. Last lesson that we did, just got done with this. So order the angles in triangle MPZ from least to greatest if MZ is 18, MP is 22, and PZ is 20. You can draw a picture. You don't need to. I will show you that I know that the least is this one. So what angle is across from MZ? Well, what letter is not in MZ? P. So angle P is the smallest. Angle M is the second, and angle Z is the third. It's the biggest. Now, I'll show you that if I draw that, MZ, I'll try to make it very clear which ones. It's not very clear, but MZ is definitely the short one. And then P here. So MZ is 18, MP is 22, and PZ is 20. Well, the smallest side is across from the smallest angle, so P is the smallest. 20 is across from M, 22 is across from Z. Okay? Order the sides in triangle CFK from greatest to least. Again, make sure you pay attention to that. If angle C is this, angle K is this, and angle F is this. Well, this one you have to do a little work. These are all the angles of a triangle, so they should add up to 180. So I'm going to do that real quick. So 2x plus 5x is 7x, plus 6x is 13x. 1 plus 8 is 9. 9 minus 11 is negative 2. And then x is going to equal whatever 182 divided by 13 is. It's going to be what? 14? I believe that's right. Let's check real quick. Okay, so that's 14. Now I'm going to plug 14 in and get each angle. So 2 times 14 plus 1 is 29. So angle C is 29. Angle K is 78, and angle F is 6 times 14 minus 11, 73. Okay, so I know now the sides. Now I'm looking at the sides. I'm not name. It'd be really, this would be a lesson 3 or unit 3 question if I asked what angles were in order. I'm asking about the sides now, knowing the angles. So angle K is the largest, so the side across from angle K is the 2 other letters. So CF is the largest side. The side across from angle F would be CK, and the side across from angle C would be KF. And that would be from greatest to least. Okay, number 41, two sides of a triangle are 16 centimeters and 25 centimeters. Write all possible lengths of the third side. There are an infinite number of lengths, so you cannot just list them. Okay? If there are whole numbers, you could list them, but they don't have to be whole numbers. What you need to see is that, let's say 25 were the longest side. That means 16 plus the missing side would have to be greater than 25. If 25 were the biggest. Okay? Solving that, you would get x is greater than 9. So I'm going to rewrite that this way. Notice that's the same thing. It's eating the x. It's eating the x. But what if x were bigger than 25? Well, then 16 plus 25 would have to be bigger than x. 16 plus 25 is 41. So x would have to be less than 41. So anywhere between 9 and 41. It could not be 9 and it could not be 41, but anywhere between 9 and 41 could be the length of the third side. Okay? There is a quicker way of doing that, but that's the explanation. 42. The side opposite the vertex angle in an isosceles triangle measures 10 inches. What must be true of the legs of the triangle? So it's an isosceles triangle, so the vertex angle is the one up here. So that's the vertex. Shouldn't put x there. I want to make x the sides over here. This is 10. Okay, so x plus x, so 2x, right? If those are larger, okay, if those are larger than 10, right, then, well, I guess let's look at 10 as the largest side. Okay, so then x plus x would have to be greater than 10. So that would be 2x has to be greater than 10. Well, then x would have to be greater than 5. But what if x were smaller, or sorry, larger than 10? Then it wouldn't really matter because you'd have two sides added up. That would, if you add 10 to it, it's going to work out. So basically, that's what you need to know right there. Okay, so x is greater than 5. X could be 100, right? 100, 100, and this is 10 because two sides have to be more than the third side. So 100 plus 10 is bigger than 100. A million and a million. A million plus 10 is bigger than a million. Okay? But it can't be less than 5. If it's 2 and 2, that's not bigger than 10. Okay? So that's what I wanted you to see there. Last one, which side is the longest? This is tricky, but I'm going to focus on triangle BCD first. In triangle BCD, well, I know that that's 61, that's 59. By knowing that there's 180 degrees, I know that this is 60. So I know in that triangle, BD is the longest. Okay? Over here, I know that this is 59 again because they add up to 180. Well, in triangle ABD, that would mean AB is the longest. AB is the longest in triangle ABD, but isn't BD also in AB, or this triangle? So AB is longest, so AB is longer than BD. So if AB is longer than BD, and that's the biggest side here, AB overall is the longest side. Okay? That's the end of this video, end of this review. Remember, this is just a quiz tomorrow.